Okay, hello everyone. Today we're going to discuss the binomial distribution. The binomial distribution deals with situations in which there are two possible results for an experiment. For example, pass or fail, man or woman, adult or child, etc. The distribution is defined in the following way: B and P, where N is the number of times an experiment or the experiment is performed, and P is the probability of success. What is success depends, of course, on the problem. So, for example, if we have B 1,1/2, that would correspond to an experiment that is performed once, and the probability of our success is half. So for example, if we throw a coin, we decide that success is getting tails. Therefore, what's the probability that the number of tails x here represent? If we define success as the number of tails, therefore, so if we define, for example, success as getting tails, then x would be the number of tails. So the probability that x is 0 would be half. Obviously, if we throw the coin once, there is a probability of half that we're going to get tail and a probability of half that we're not going to get tail. The probability of getting one tail, is also half. Obviously, we cannot get more than one tail if we perform the experiment just once. B 2/2 would be the same, just throwing a coin twice. And again, if we define success as getting tails, then here we can get the probability of getting 0 tails would be getting heads and head. That's the probability, of course, is 1/4. The probability of getting 1 tails would be 1/2, and the probability of getting 2 tails is 1/4. How did I get these numbers? Just build a tree diagram, for example. So that's head and tails, head and tails, head and tails, and each one of them has probability of half and half. So for example, getting tails and head will be half times half. That gives me this 1/4. Getting 0 tails means getting head and head, means again half and half, half times half, 1/4. And the probability of 1 tail would be half times half from here plus half times half from here, so 1/2. If the experiment, for example, was performed 3 times, the tree diagram becomes much bigger. But for example, if the experiment is performed 10 times, we cannot build a tree diagram with 10 branches. That is very uncomfortable, and that's why we need the binomial distribution. Therefore, it results that these numbers here can be obtained in the following way, meaning the probability that x has a certain value is n/k times the probability of p to the power of k times the probability of 1 minus p, or q 1 minus p to the power of n minus k. So for example, if we perform the experiment 10 times, we want to know, for example, what's the probability that we get 4 tails? That would be 10, that's 10, the number of times the experiment takes place. The 4 is k, 10/4, times the probability for success, which is half, to the power of k, which is 4, times 1 minus half, which is also half, to the power of 10 minus 4, which is 6. If we want to calculate this, this is of course 10 factorial over 4 factorial, 6 factorial. And here we have 1 over 2 to the power of 10. This gives 10 times 9 times 8 times 7 over 4 times 3 times 2 times 2 to the 10. So 4 and 2 cancel with the 8, the 3 cancel with the 9 to give a 3. So we get 30 times 7, that's 210 over 2 to the power of 10. So 210 over 1024. That's the probability of getting 4 tails if we throw the coin 10 times. For example, if we have an experiment B 916, that could be an experiment in which we throw a die and our success, what we call success, is getting a 6. Therefore, for example, what's the probability we get 3 6s? 3 6s in this experiment, that of course would be 9 over 3, again n and k, then the probability of success, which is 1/6 to the power of k to the power of 3, times the probability of 1 minus p, which is 5/6. 1 minus 1/6, 1/6, 5/6, and to the power of n minus k, which is in this case 6. Once again, this is 9 factorial over 3 factorial, 6 factorial, times 5 to the power of 6 over 6 to the power of 9. This is 9 times 8 times 7 over 3 times 2 times 5 to the 6 over 9 to the 6. This cancels with this to give a 3, this with this to give a 4. So we get 84 times 5 to the 6 over 9 to the 6. You can use a calculator to obtain these numbers, but that's how you find the probability of getting 3 6s when you throw a die 9 times.